Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Hadi bin Miri. For this presentation, we will cover four main sections. First, we will introduce the background and purpose. Introduction. Oil palm plantation operation require proper machinery planning to ensure that every field activity can be completed efficiently, economically, and within the required working period. For this project, we selected two mechanized field operations. The first operation is mechanical slashing using a tractor-mounted rotary slasher. This operation is carried out
for the computation. We use as a management tool to mathematically prove the exact fleet size required for operational timeline, establish an accurate operation budget, and economically justify owning the machinery over hiring a contractor. So in our farm estate, we use two operational operation, which is mechanical slashing and boom sprayer. So the machine system require 55 kilowatt plus 1.8 rotary slasher and 55 kilowatt plus 6 meter boom sprayer. The purpose is to control weight and to maintain a field access. So let's go slide by slide. Moving on to our computational method, let's look at operation 1, mechanical slashing. Our primary objective here is to manage weed growth and keep field access clear across the 500 hectare estate. For this operation, we selected a 55 kilowatt tractor paired with a 1.8 meter rotary slasher, coming to a total machine unit price of RM67,000, operating at a speed of 5 km per hour with an estimated field efficiency of 75%. We calculate the theoretical field capacity TFC at 0.90 hectare per hour and the effective field capacity EFC at 0.675 hectare per hour. With 4 slashing rounds required annually, our total yearly coverage comes to 2,000 hectares. To ensure field operations are complete within a strict timeline of 20 working days per round, assuming 8 hours workday, a single machine can cover 1 108 hectare per round. Dividing the total required hour by our available time frame give us a requirement of 4.63 units. Therefore, our plantation require a fleet of 5 tractor slasher unit, giving each unit approximately 572.59 annual working hour. Next, let's examine operation 2, herbicide spraying, which cover chemical weed control across our block. For this setup, we opted for a slightly smaller 45 kilowatt tractor coupled with a wide 6.0 meter boom sprayer, representing a total unit investment of 60,000. Because of the wider boom sprayer, representing a total unit investment of 60,000. Because of the wider implement width, even at a lower operating speed of 4.5 km per hour and a conservative field efficiency of 65%. The system achieved a much higher effective field capacity of 1.755 hectare per hour. We have planned for 3 spraying rounds per year, bringing the annual coverage to 1,500 hectare, targeting completion within 15 working days per round or 120 available working hour. One machine system can cover roughly around 210 hectare per round. This means our 500 hectare estate require 2.37 units, which round up to a fleet of 3 tractor boom sprayer unit. This will distribute the workload to 284.09 annual working hours per year. Okay, next, let's dive into the financial metrics, starting with the cost analysis for mechanical slashing. Looking at our feed cost, we factored in a 2000 salvage value over an 8-year lifespan, combined with interest at 6% plus tax, insurance and shelter at 2%. The feed cost come to RM10,452 ringgit annually per year. For our entire fleet of 5 units, this equates to 52,260 per year, or RM26 ringgit, 26 ringgit 13 per hectare. Turning to operating costs, fuel is our largest hourly expenses at RM48 ringgit 69 per hour, assuming a consumption rate of 12.265 liter per hour at RM3 ringgit 97 per liter. Adding 10% for lubricant, RM6 ringgit 78 cent for maintenance, and RM10 for labor. Our total operating cost sit at 70 ringgit 35 per hour. When mapped to our field capacity, this translates to RM 104.21 cent per hectare, or an annual operating cost of RM 208 ringgit for 2008 420 ringgit. Combining both feed and operating costs, the total operational cost for mechanical slashing is RM 1 130 ringgit.34 per hectare, bringing our total annual fleet expenditure for slashing to RM 2,680 ringgit.
Okay, hi, I'm Atira. So let's continue to computation of the operation 2, which is herbicide spraying. So in this segment, we will calculate the fixed cost and operating cost of this machinery. So in this fixed cost, we have calculate the depreciation, interest, annual tax and insurance, total fixed, and we will see the total fixed cost per unit. So the total fixed cost per unit is 9,360 per year, and we times 3 for 3 units, which is cost about 28,080 per year, and per hectare cost about 18 ringgit per 0.72 per hectare, and the operating cost is included fuel, lubricant cost and repair maintenance, which is annual operation cost about 56,805 ringgit per year. This is the operating cost and fixed cost. And let's continue to the computation of the chemical cost of spraying. We decided to use two chemicals, which is glyphosate and metasulfuromethyl, which is cost about 56 for glyphosate, cost about 56 ringgit per hectare, and also metasulfuromethyl 48 cents cost per hectare. And the total spraying cost including chemical is RM 113.07 per hectare, and annual chemical cost, which is 84,720 per year. Then let's move to the financial summary of machinery cost. In this project, we have two machinery, which is mechanical slashing and boom spraying. So the total cost of both of these machinery, excluding chemical, is 345,572.07 per year. And cost per hectare we divided into 500 hectare, which we have gained about RM 691.14 hectare per year. This is excluded chemical. Okay, for the total cost including chemical, for the total annual cost including chemical, we have defined RM 430 and 292.07 per year. And per hectare, we have divided into 500 hectare, which is we gain about RM 860.58 per hectare and per year. Okay, let's move to the computation of the BEP of both mechanization. For BEP is the break-even point of this mechanization of both mechanical slashing fleet depreciation and boom sprayer. So in this segment, we will decide either to renting or owning and mechanization to compute our operation. So in this calculation, we have decided a mechanical slashing fleet depreciation is the best of owning than renting. In this calculation, we have seen that we can save about 59,320 ringgit per year if we owning this machinery. And for the boom sprayer, also owning is better than renting, which is we can save about 20,115 ringgit per year. So both machinery we have decided to owning better than renting. We can save so many costs of this machinery.
Okay, hello. My name is Muhammad Shuim. For my part, is about discussion. These slides This slide compares mechanical slashing and boom spraying for 500 hectare plantation. For mechanical slashing, 5 units are needed because the implement width is only 1.8 meters. The effective field capacity is 0.675 hectare per hour. This operation is done 4 times per year. The own machine cost is 130 ringgit and 34 cents per hectare, while the contractor rate is 160 ringgit per hectare. Contractor service is preferred when reliable operation is needed. Besides that, for boom spraying is only 3 units are required because the implement width is 6 meter. The effective field capacity is 1.755 hectare per hour, which is much higher. So now the own machine cost is 56 ringgit and 59 cents per hectare, compared to the contractor rate of 70 ringgit per hectare. Owning machine can save 20,115 ringgit per year. In conclusion, boom spraying is more efficient, more economical. However, its performance depends on weather condition and proper sprayer calibration. Mechanical slashing is still important for maintaining field access and controlling weight. In conclusion, this project helps us understand the importance of mechanization planning in plantation management. We learn how to calculate field capacity, mission requirement, and operating costs. We also compare cost of owning machine and hiring contractor using break-even analysis. Overall, boom spraying is more efficient and cost-effective, while mechanical slashing is still important for certain field conditions. This project also improve our skill in calculation, teamwork, report writing, and presentation.